Hi, we are the Group 2, and we are here to discuss problems involving rolling contacts. So sit back and relax.
Today guys, I am John Vincent Cabezas and I'm going to show you the number 4 problem which is seen in the screen. And the initial values that given are the A, or the larger diameter gear, has 30 revolutions per minute, and the smaller one has a 90 revolutions per minute, which is 1/3 of the original, or the bigger gear diameter. Then the angle of 45 degrees between the two. This is concentric to each other. This one concentric to the gear, the A and the B. And alpha here from the center line of A to its to the radius of this one. This is the alpha. That's the angle that it produces from this point. This is the origin, or this is the point of contact where every line meets from A and B gears. It's the common point of contact. And from that, we have the formula here. We have the formula: tangent of beta is equal to sine theta all over NA, or the speed of A, which is 30 rpm here, 30 rpm, divided by the speed of B, this one 90 rpm, minus the cosine of 45 degrees theta. So rearranging the formula to get the beta, which is beta is what we need in the problem, is needed in the problem. So here the inverse of tangent and quantity of sine theta all over NA over NB minus the cosine theta. And here plugging in the 45 degrees, which is given, and 30 revolutions per minute divided by 90 revolutions per minute minus the cosine of 45 degrees, we have the answer of 42.1393 degrees, or approximately 63 degrees. And that is how we managed to get the answer from the problem.
For problem number 1, two parallel shafts connected by rolling cylinders turn in the same direction, 157 rpm and 116.7 rpm respectively. The smaller cylinder is 18.45 inches in diameter. How far are the axes of the shaft in inches? So, as for the given, let's write all the given. For N1, we have 157 rpm. N2 is equals to 116.7 rpm. And since the given for the smaller cylinder has a diameter of 18.45, therefore D1 divided by 2 equals R1, which is equal to 18.45 divided by 2 would be equal to 9.225 inches. In the problem, it is stated that the cylinder turns in the same direction. Therefore, the rolling cylinder has the internal contact without slipping. Now, for the solution, we know that the cylinder has internal contact. Therefore, to determine the distance of the axis in inches, we will have R2 minus R1 equals C, which is the distance of the axis of the cylinders. To get R2, we have the formula 2 pi n1 r1 equals 2 pi n2 r2. Since by ratio and proportion, we can easily get that n1 over n2 would be equal to r1 r2 over r1. Since 2 pi is present on both sides, it can be cancelled out. Then plug in the givens, which will be for n1 157 rpm divided by 116.7 rpm, which is equals to r2, we didn't have, which is the unknown, and then the r1 of 9.225 inches. To solve for r2, it would be equal to 157 times 9.225 inches over 1167 rpm. 167 and 157 are just both rpm, so it would be cancelled out. Then we will have the unit remain inches. Therefore, r2 is equals to 12.41066838 inches. Since we already have the values for our r1 and r2, we can use this formula to solve the distance of the axis. So r2, we have r2 of 12.41066838 minus the value for r1 in the radius of r1 in inches of 9.225. It would be equal to 3.185663838 inches, or just approximately 3.186 inches. There you go. We have already the distance of the axis of the cylinders.
So, good morning, sir. I'm Charles Asa. So, we're given a task to solve and explain the questions. So, here's my answer in group activity number 2. So, the problem: two parallel shafts 14.06 inches apart and rotating at 41 rpm and 184 rpm are connected by cylinders in a rolling contact. Determine the diameter in inches of the larger cylinder when they turn the opposite direction. So, as you analyze the problem, so it has given two rolling contacts. So, by just looking, makita nimo if the higher RPM, the smaller. So, compare sa dako nga diameter. So, akong gibutang ang N2 is equals to 41 RPM niya. R2 is ato magitaon, then N1 is equals to 184 and R1 missing. So, the formula is C equals R1 plus R2. So, since we have already given sa value sa C, so ato i-input, then R1 is equals to 14.06 equals R2. So, to find the answer, so atong gamitan formula nga N2 over N1 equals R1 over R2. So, ato i-input ang atong mga given. So, N2 is equals to 41 over 184, which 184, ang R1 kay 14.06, R2 since na natay value diri sa taas, which is kani sa R2, then cross multiply. So 41 184, we come cross multiply, so ato nakuha ang results, then add same terms. So 41 plus 184 equals to 587.06. so we get the value of R2, which is 11.4979556. So since we are task to find the diameter. So after siya is squared or times 2, so we get the result of 23 inches. That's all, sir.
We will be solving the group activity number 3. So the two shafts having axes in the same plane intersecting at an angle of 45 degrees. Turn in opposite senses at 30 rpm and 90 rpm. The diameter of the base of the smaller cone is 1 inch. Calculate the cone angle of the larger cone in degrees. So first, the problem says that it rotates in opposite direction. And you should take note of the speed of the cones. So the first cone, which is NA, is equals to 30 rpm. And the second cone is 90 rpm. And the angle is 45 degrees. So, as you can see that NB, or the second cone, has greater RPM than NA. So it means that it has lesser diameter than the first cone, which is NA. So next, we draw the schematic diagram for the problem. So here, the second cone or shaft, it is 1 inch, and here we labeled all the necessary angles. The first is the alpha and the beta. So in getting the angle of the cone, of the larger cone in degrees, there is a formula. The derived formula is equals to tan alpha is equals to sine theta over NA over NB plus cos theta. So you substitute the values, the given values and angles. So tan alpha is equals to sine 45 degrees over 30, which is the speed of the cones, over 90 plus cosine 45 degrees. So we get the value of tan alpha 0.67962, and we obtain the alpha value by getting the inverse tangent of that, and we get 34.2009 degrees. And that is all.